Raval AP Stats quiz video. Okay, the Bayside High School swim team competes in a 4-person relay event in which each team member swims 100 meters. The coach creates a model for the team's times. Assuming that the swimmers' times are independent and normally distributed, the mean and standard deviation are shown. So I'm going to bring the camera up a little closer so it's easier to see some things that I've highlighted that will be essential for solving the problem later, and the data that was shown. So here we can see all the data that was given. I've highlighted that, and we can see some of the standard deviation. And additionally, in the question it says assuming independent and normally distributed. This will help us later on in solving the problem. So part A asks us to find the mean and standard deviation. So to find these two things, we need to remember formulas from class. This one is one of the formulas we learned. So to find the mean of all of this data set, we have to add up the means here. And so that would be, mean of x is equal to mean of 1 plus 2 plus 3 plus 4, etc., etc., etc. So applied to our question, this would be mean of x is equal to 50.72 plus 55.71 plus 49.93 plus 44.91. And all of that added up together is 200.57. And that is the mean of x. And mean of x just means the mean for total relay time. And again, this is all of this added up. So we're trying to find the mean and standard deviation of all of this. But right now we're focusing on the mean. So we're trying to find the mean of all of this. Now to focus on the standard deviation, this is again a formula we learned in class. So standard deviation of x is equal to the square root of standard deviation of 1 squared plus standard deviation of 2 squared plus standard deviation of 3 squared, etc., etc., etc. And again, just like this, we're going to apply it to our question, where the standard deviation of x is equal to 0.24 squared plus 0.22 squared plus 0.25 squared plus 0.21 squared, right? And all of this data is given to us here, and that gives us 0.461, and so the standard deviation is 0.461. Now, the question asks, for part B, the question asks, the team's best time so far in this season has been 199.48 seconds. Do you think the team is likely to swim faster the next meet? Before starting, I made a prediction where I said they will not swim faster the next meet. And so again, we're gonna go back to the question, and it says normally distributed and independent. So now we know that we can use a certain formula, a calculator formula. And so in the calculator, there's a function called normal CDF, which will help us solve this problem because it'll help us determine the probability of them swimming this. So in our normal CDF parts, we have lower, upper, mean, and standard deviation. The mean and standard deviation we found before thanks to the help of question A. And so remember, the mean and standard deviation were 200.57 and 4.461 for mean and standard deviation respectively. Now for the upper bound, we put 0.19948 because we want to find the probability that if they're going to break this or not, and then the lower will be right as low as they can go. And so when we put all of this into the calculator and it's each respective spot, we get probability of 0.009029, and this is what it looks like graphed. It's less than 1%, so this is a very unlikely possibility. And so the probability of them swimming faster than their best time the next meet is 0.009029, meaning it is extremely unlikely, and it's less than 1%, so it can be implied that way. This was Raval AP Stats quiz video.